Welcome to the Volume Graphics tutorials. In this video, I will show you how to use a fixture simulation in an automated workflow. In the first part, we will perform a fixture simulation on an actual part, calculate a nominal actual comparison between actual and nominal part, place the fixtured object in the scene, and calculate a nominal actual comparison between fixtured object and nominal part. In the second part, we will record a macro for each step and combine the macros to a job that can be used in the fully automated VGinLINE system. In the third part, we will run the job on the original project and finally view and compare the analysis results. So that we can start right away, I have prepared a project that already contains all the objects we need to set up our automated workflow. Let's get started. Remember, first we want to perform the fixture simulation. Place the fixtured object in the scene and calculate the nominal actual comparisons. I'll open VG Studio Max, select File, Open, browse for the fixture simulation VGL file, and click Open. In the scene tree, we have the nominal object, nominal mesh, the actual object, volume 1, and the base plate on which the actual object is to be fixed. All necessary preparatory steps such as surface determination and alignment are already done. We can immediately start and perform the fixture simulation for the actual object. Therefore, I'll select Volume 1, the actual object, and go to Analysis, Fixture Simulation. Here I need to select the fixture ROI, in our case the base plate, from the ROI 1 drop-down list. Our object will be fixed on the base plate in Z direction, so I can deactivate the checkboxes in front of the X and Y directions. The calculation might take a few minutes. As soon as it has been completed, we can close the dialog. As you can see, Analysis 1 has been added to the scene tree under Fixture Simulation. Next, I will perform the nominal actual comparison between actual and nominal object. I'll highlight Volume 1 and go to Analysis, Nominal Actual Comparison. Here I'll set the max distance to 1.2 millimeters. To save calculation time, I'll select Performance from the Mode drop-down list. For all other options, I can keep the default settings and click Calculate. To run an analysis in an automated workflow, we need to create an evaluation template that can be imported as a macro step. To do so, we will export an evaluation template that includes the fixture simulation and the nominal actual comparison for the actual object. I'll right-click Volume 1, select Export Evaluations from the context menu, and save the template under the name Fixture Simulation and NAC. If I want, I can add some information here. Then I'll click Save again, and the template will be saved in the specified location. Our next step would be the nominal actual comparison between the simulated fixtured object and the nominal object. But the fixtured object is part of the fixture simulation analysis. Since we cannot run an analysis on another analysis, we first need to place the fixtured object in the scene. For this, I'll highlight Analysis 1 of the fixture simulation, and on the Analysis tab, I'll select Place Fixtured Mesh in Scene from the Fixture Simulation drop-down list. This adds a mesh to the scene tree that represents the assembled state of the actual object. Now we can perform the nominal actual comparison between the fixtured object and the nominal object. I'll highlight the fixtured mesh and again open the Nominal Actual Comparison dialog via Analysis, Nominal Actual Comparison. I'll select the nominal object, nominal mesh, and specify the same settings as before. Then I'll click Calculate and close the dialog when the calculation has finished. And that's all we need for our second evaluation template. To export it, I'll highlight the fixtured object, select Export, evaluations, and save the template as fixtured object NAC. The first part is done. We can clear the scene by selecting File, New without saving the project. Next, we will create a macro for each step and combine the macros to a VGinLINE job. Therefore, I'll open the original Fixture Simulation VGL project again. Let me check whether the Automation tool is available in the tool dock. If not, I can add it by activating Automation in the Tools drop-down list on the Window tab. Let me just release the Automation tool from the tool dock and place it in the middle of the scene. This makes it easier to work with. For our automated workflow, we need to record 3 macros that include the following steps. Import the first evaluation template, place the fixtured object in the scene, and import the second evaluation template. I'll start with the macro that imports the fixture simulation and the nominal actual comparison between actual and nominal object. I'll click Record Macro, right-click Volume 1 and select Import Evaluations from the context menu. I'll browse for the fixture simulation and NAC's VG evaluation template file and click Open. Here I can keep the default settings and click OK. As soon as the evaluation template has been imported, I can stop the recording. With that, the macro step Import Evaluation Template will appear in the Automation tool. Our next macro will place the fixtured object in the scene. I'll start the recording again. In the Scene tree, I'll click Analysis 1 under Fixture Simulation, and on the Analysis tab, I'll select Place Fixtured Mesh in Scene from the Fixture Simulation drop-down list. After the recording has been stopped, a new macro step, Create Fixtured Object in Scene, will be shown in the Automation tool. Finally, I'll record the macro to import the nominal actual comparison between fixtured object and nominal object. Once again, I'll click the Record Macro button. This time I'll select the fixtured object in the Scene tree to import the fixtured object NATXVGE template file. Now that all the macros have been recorded, we can organize them and create a job for VGinLINE. For this, we need some additional options, which are available in the Advanced dialog of the Automation tool. I'll click Advanced to open the Automation Advanced dialog. On the left-hand side, you can see our 3 macros. By clicking the triangle in front of each macro, we can expand them to see which action they include. It's always a good idea to name each macro according to the corresponding action and save it. Let me just do this by selecting the first macro and clicking the Save button here. The Save Macro dialog will open under the path where the evaluation template associated to the macro had been saved. I'll add a name for the first macro and click Save. I'll repeat this step, choosing a suitable name for each macro. If necessary, for example, if you want to adjust the settings for the nominal actual comparisons, you can now exchange the evaluation templates at any time. Remember, for this video tutorial, we wanted to create a job that can be used in VGinLINE. Therefore, I'll highlight the macros and click Create Job from Macros. In this wizard, I need to enter a name, for example, Automated Fixture Simulation. Then I'll click Next to proceed to the Steps dialog. This dialog shows an overview of the available macros and provides several options to rearrange them and to add additional macros. In this case, I want the final project to be saved after the job has been processed. To add a corresponding macro step, I'll click the Save button here. And that's all we need to do to make our job run. I'll click Next until the Finish button appears and click it to close the job wizard. The new job is now visible in the Automation tool. By clicking the little triangle in front of the job, you can expand it and see whether all necessary steps are included. Our job has been created successfully. All necessary steps are there. I'll click Save to save the job. After that, I'll click File, Quit to close the application without saving the project. Now comes the exciting part. We will try out the automated workflow and take a look at the results. I'll restart VG Studio Max and select File Open. I'll select the original fixture simulation VGL file. In the Automation tool, I'll click Load, browse for the Automated Fixture Simulation X VGJ file to load the job, and click Run Job. In this dialog, I need to create an output folder where the final project will be saved. To keep it simple, I'll name it Output. Then I can click Select Folder to start playing back the job. It might take a while until all macro steps will be processed. After the job has been completed, I can drag the Automation tool back into the tool dock. I won't need it anymore. To view the job results, I'll click the Expand All icon at the top of the Scene Tree tool. Now we can see all the objects and analyses that have been created. What we want to do now, and that's the real purpose of our workflow, is compare the results of the nominal actual comparisons between actual and nominal object and between fixtured object and nominal object. For a better visualization, I'll click the little toggle full screen state icon down here to set the 3D window to full screen. In the scene tree, I'll set all objects to invisible except for the fixtured object, the volume object, and the associated nominal actual comparisons. Okay, now let's deactivate the checkbox in front of the fixtured object to visualize only the deviations resulting from the nominal actual comparison between actual and nominal object. Let me quickly check whether the live value option is activated on the Analysis tab. Okay, with the live value option activated, the deviation value will be displayed at the corresponding cursor position. As you can see, there are significant deviations at the top left and the top right, as well as some minor deviations at the bottom of the object. Now, what about the fixtured object? Let's have a look at the deviations there. In the scene tree, I'll toggle the visibility state of the volume object and the fixtured object by activating and deactivating the corresponding checkboxes. On the fixtured object, the deviations have almost completely disappeared. There aren't any deviations on the right and only a few minor spots on the left and at the bottom. And that's it. I hope you enjoyed this tutorial. If you want to learn more, be sure to check out our documentation landing page via Help, Show Tutorials. Plus, make sure to register on Nexus and make it your go-to place for sharpening your expertise. Get access to this video and other information material to get the best out of our software. And visit the VG community to exchange ideas, ask questions, and discuss topics with other users and our Hexagon experts, and stay up to date on the latest news and developments. Register now, a world of insight awaits. Thanks for watching, and see you soon on Nexus.